Our universe holds more planets than grains of sand on every beach on Earth. But maybe not anymore. Yet so far, only one, our blue marble, has shown signs of life. Why is this? Is life just incredibly rare? Or are we simply not looking hard enough? Astronomers around the world are racing to answer this mystery. They scour the Milky Way for a planet like ours, an Earth twin. A rocky sphere wrapped in oceans, cloaked in clouds, and perhaps alive with strange, unimaginable creatures. Just a century ago, this quest would have seemed like pure science fiction. Back then, even Pluto was still undiscovered. But today, each day brings new discoveries, bold headlines, and cosmic clues. Many scientists now argue we may already have glimpsed life from afar. At the heart of this search lie exoplanets, planets orbiting stars far beyond our Sun. For centuries, they were the stuff of speculation. Ancient philosophers dreamed of other Earths, but lacked the tools to prove their existence. In the late 1500s, Italian philosopher Giordano Bruno proposed that the universe was filled with suns like ours, each surrounded by its own family of planets. His ideas were deemed heretical, and he was burned at the stake in 1600. A tragic end, possibly history's first exoplanet martyr. But Bruno was right. Fast forward to today, over 5,500 exoplanets have been confirmed. And more than 10,000 candidates await validation. Each new world pushes the boundaries of what we thought possible. We've discovered gas giants with rings 600 times larger than Saturn's. Planets so hot they rain molten glass sideways in ferocious winds. Ocean worlds covered entirely in water, no land in sight. Even rogue planets, wanderers drifting through space with no star to orbit. 5,000 might sound impressive, but consider this. The Milky Way contains between 100 and 200 billion stars. Most of these likely host planets. That's potentially trillions of worlds, and we've barely scratched the surface. Yet finding these planets is no small task. Imagine trying to spot a firefly circling a lighthouse from thousands of miles away. The glare from a star makes its planets almost invisible. Only 69 exoplanets have been seen directly. To get around this, astronomers use clever tricks. Coronagraphs and star shades help block out the star's light, allowing us to glimpse massive, far-flung planets, like super Jupiters orbiting far from their stars. But spotting an Earth twin, tucked in close? That's far harder. That's where the radial velocity method comes in. It detects the tiny wobbles in a star's motion caused by an orbiting planet. This technique has revealed over 1,000 exoplanets. But it's best at finding big planets that orbit close in. Smaller, Earth-like planets barely move their stars at all. Our most successful method is the transit technique. When a planet crosses in front of its star, it causes a tiny, regular dip in brightness. Think of it like a moth flying across a light bulb. NASA's Kepler mission used this method to survey over 500,000 stars. It revolutionized our understanding of the galaxy. Over 80% of confirmed exoplanets were found this way. Among them is TRAPPIST-1, a system with 7 rocky planets, 3 of which lie in the habitable zone, the sweet spot where liquid water could exist. These are among our top targets in the search for alien life. And we're just getting started. The James Webb Space Telescope is now peering into their atmospheres. Its infrared sensors can detect the fingerprints of molecules, including potential biosignatures like methane or oxygen. More missions are coming soon. The European Space Agency's Plato, launching in 2026, will study 1 million stars for Earth-like planets. NASA's Pandora, set for autumn 2025, will examine the atmospheres of 24 promising worlds. Then there's the Roman Space Telescope, arriving in 2027, which will scan the galaxy for distant planets and dark matter. And ESA's Ariel, in 2029, will sniff the skies of exoplanets for chemical clues, water vapor, carbon dioxide, maybe more. Why does this matter? Because when light from a distant star passes through a planet's atmosphere, it gets filtered by the gases present. The result is a kind of chemical signature, a barcode revealing the planet's ingredients. Recently, one such signature caught the world's attention. On K218b, a mini-Neptune, 120 light-years away, scientists detected dimethyl sulfide, a compound produced by life on Earth, primarily by ocean-dwelling microbes. While not proof, it's a tantalizing hint. Follow-up observations are already underway. And that's the thing. We're no longer asking if life exists elsewhere. Now, we're asking where, and when we'll find it. I truly believe we're getting close. With current and upcoming technologies, we might detect definitive signs of life in the next decade or two. When that happens, it will be a moment unlike any in human history. A revelation that reshapes religion, philosophy, science, and our understanding of what it means to be alive. Yet, even with all this progress, we must remember, Earth is still our only home. Traveling to even the closest star system, Proxima Centauri, would take over 10,000 years with today's spacecraft. But that doesn't mean the search is futile. Our curiosity drives us. Our questions demand answers. And if we don't look, we'll never know. Even a faint whisper of life on another world would mean we are not alone in the cosmos. So we keep watching the skies, measuring shadows, analyzing starlight, listening for signs. Because the truth is out there. And someday soon, we just might find it. If you enjoyed this video, please consider liking and subscribing as we delve into more space discoveries.